everybody. So we're going to be starting chapter 5 today. So in this lesson, we're going to be going through the Pythagorean Theorem, which is a topic that we already covered, but it does come up a lot in this chapter. So it's just going to be a little refresher. Once you're done with this, the notes that I'm about to go through, we just have a small assignment that we want you to complete, and that's out of the textbook. So if you need help getting onto the textbook, there are instructions that were posted in the beginning of the semester right on Google Classroom. But if you do need a tutorial, just let us know. You can pop online to Google Meet and we can help you out with that. Okay, so for the first one, parts of a right triangle, sides A and B, those are called the legs. They're adjacent to the right angle. And then side C, that's called your hypotenuse. The Pythagorean theorem is used to find the missing side lengths in a right triangle. So specifically, it must be a right triangle. And then the formula, as you know, it is a squared plus b squared equals c squared, or c squared equals a squared plus b squared, however you like to write it. I'll write it as a squared plus b squared equals c squared. Okay, so just remember that c is your hypotenuse, so that's really the important one. So when we go to question 1, the hypotenuse is x, so that's going to be our c. Our other two are going to be a and b. So it doesn't matter which one's a or b. You can just kind of pick whichever one. I'll say that 7 is your A and 8 is your B. And then we're just going to plug it into the Pythagorean theorem. So A squared, that would be 7 squared, plus B squared, that would be 8 squared, equals C squared. And in this case, we'll use X. Okay, you'll need a calculator for this because the directions do say round to the nearest tenth. So 7 squared, that's 49, plus 8 squared is 64, equals X squared. Next, you're going to do 64 plus 49. You should get 113 equals x squared. And then our last step, once we have x squared equals a number, we're going to do the square root of x squared. So do the square root of both sides. And we end up, x is approximately, because 113 is not a perfect square. So in your calculator, you're going to do the square root of 113. And you should get approximately 10.6. Okay, if you want to go on and do the rest of them and just pause the video, feel free to do that, and then you can check. I'm going to go through the rest of them right now. Okay, the next one, our C is going to be the X again, and then A and B would be the other two. So I'll say 15 is A, and 18 is B. So A squared plus B squared equals C squared. That's going to be written as 15 squared plus 18 squared equals X squared. 15 squared, that's 225. Plus 18 squared, that is 324. Add those two together, 225 plus 324. You should get 549 equals x squared. And then again, last step, when x squared is by itself, take the square root. So the square root of 549 is about 23.4. So x is approximately 23.4. Okay, number 3. In this case, 13 is our C, so the hypotenuse. It's across from the right angle. And then A and B would be our other two sides. So A I'll call 6, B will be x. So we're going to do 6 squared plus x squared equals 13 squared. So same step as before, we're going to simplify 6 squared. That's going to be 36 plus x squared equals, and then 13 squared is 169. Now the only difference with this type of question is the x squared isn't by itself now. We have to subtract 36 from both sides. So we get x squared equals 133. And then just like before, our last step is once x squared is by itself, do the square root of both sides. So the square root of 133, 11.5. Okay, number 4. Again, if you're feeling confident, just hit pause, go on, and you can come back and check them in a little bit. So C is 30, we'll say A is x, and B is 25. So we're going to do x squared plus 25 squared equals 30 squared. So we get x squared. 25 squared is 625. And then 30 squared is 900. Subtract 625 from both sides. We get x squared equals 275. And then do the square root of 275. And you get 16.6. All right, so 2 more. Number 5. Our C is 20. So then A and B would be 12 and x. So we're going to do 12 squared plus x squared equals 20 squared. So we get 144 plus x squared equals 400. And then subtract 144 from both sides. We get x squared equals 256. That number sounds like a perfect square. When you do the square root, we actually end up getting a whole number. X is exactly 16. So those are the type that are nice. And then number 6. Number 49, so 49 is C. We'll call x A and we'll call 44 B. So we'll do x squared plus 44 squared equals 49 squared. So we get x squared plus 44 squared is 1,936 equals 49 squared, which is 2,401. Subtract the 1,936 from both sides. And we get x squared equals 465. And then do the square root of 465. I get approximately 21.6. Okay, so that's the Pythagorean theorem. So you guys are going to have these questions to do. I'll post these on Google Classroom as well, bookwork. So you're going to log into the online textbook, or you actually should have your textbook at home with you as well. Page 365, numbers 15, 16, and then 19, 20, and 21. Okay, have a great day. Let us know if you have any questions.